Hi everyone, welcome to our event. This event is brought to you by DataTalksClub, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have, there is a link in the description. So click on this link and check it out. And chances are you're here because you're taking our MLOps Zoom Camp course. So while I think most of you who are the students of that course will find this talk today very relevant. If you're not a student of the course, there is also a link in the description to the course. So check it out and enroll if you're interested in MLOps. Do not forget to subscribe to our YouTube channel. So click on that subscribe button. This way you will get notifications about all future streams like the one we have today. And we have an amazing Slack community where you can hang out with other data enthusiasts. And if you're taking a course, you're probably already there. But if you're taking a course and you're not there, you definitely need to join because there is a channel for talking about the course. And then finally, during today's presentation, you can ask any question you want. And the question to you, Magdalena, do you prefer questions at the end or during the talk?
Maybe if it's not too pressing, then at the end. Okay. And I think my talk will be 30 to 40 minutes, so then we have still 20 minutes left for questions.
So ask your questions during the presentation, but then we will be covering these questions at the end. So that's all the slides I have. And now the floor is yours. Please start. You hopefully should be able to share your screen, I hope.
Okay, so now you should see my screen.
I see a car. It's a BMW. Okay.
Yeah, I mean, what else? What did you expect?
Audi?
No, it's a BMW. We're based in Munich. The whole name is Bayerische Motorenwerke, in case you haven't heard. So yeah. Today, I will introduce you to the topic at hand, like why companies would want to invest in an internal machine learning platform, and also which kind of use cases our connected AI platform is made for. And then second, it'll be all about the features and architecture of the connected AI platform. And then I'll share some learnings around how to successfully onboard a diverse range of data scientists. And then before sharing some learning resources and jumping into a Q&A, I want to highlight some topics that go along with developing a platform and that can be easily overseen, or rather like we also kind of oversaw them at the beginning, but now over time, we gathered more and more learnings. So, I assume that for most of the people in this call, it's quite obvious why a company would want to invest in a dedicated ML platform. So let's take this as a smooth intro. During the typical data science workflow, the data scientist has to accomplish several steps, from like data collection and cleaning to model experimentation. And then once it's ready, like the model is ready, it needs to be properly deployed and maintained. And then as soon as you have more than, let's say, a handful of use cases, you want to streamline the efforts around reusable tooling and helper functionality and properly support your data scientists in your company. So that's why we want to provide a machine learning platform. And then from a data scientist point of view, so you would need to master a bunch of skills in order to deploy your models to production. So probably the first couple of bullet points are the ones that you as a data scientist enjoy the most. And that's what you also expect when starting a data science full-time position. But then the other ones are more, I would say, maybe an add-on, and that you would only do if necessary, like get into the details of maybe integration testing, Kubernetes, Docker, Prometheus, and all this stack. But if you as a company offer a well-functioning machine learning platform, then the data scientists can really focus on the business problem at hand, like feature engineering, modeling, and don't have to be this like unicorn data scientists, which will be very rare to achieve, I guess. And then from the other point of view, from a company point of view, you might end up with some like a bunch of custom one-off solutions per data science project team that might be hard to maintain. But that's actually what happens if you don't offer a machine learning platform. Then obviously the data scientists come up with their custom solutions. And then speaking in pictures, you don't want everyone to travel to a destination with their own little boat, but instead you want to use something like a cargo ship that fits more than a couple of people in containers. And then if you apply this to data science, it just makes sense to combine the efforts by a central and specialized engineering team so that you can leverage synergies across data science teams. Then another important question when kickstarting an internal machine learning platform. So you have the options build or buy. So if you decide to go with build, then you would hire a team dedicated to build the platform in-house. Advantages would be you have the full range of customizability and you have less vendor lock-in. I'm specifically saying less because I personally can't imagine like a cloud-based machine learning platform that is really 100% independent of cloud services. And I think that's also not desired. Like you want to take advantage of their services. But it's just like easier to port it to other cloud vendors if you have to do so. Disadvantages of building a platform in-house is, of course, like you do have an effort of development, maintenance, and operation that you also shouldn't underestimate. Then on the right-hand side, you can also buy from one of the major cloud providers. The advantages are like you can really start quickly with everything, and there's by now also a very broad set of features. Disadvantages, okay, like you are kind of tied to this vendor. You might run into difficult situations when they decide to raise their prices, or if there's some missing features. So then you're like, you have to wait for their releases. So in order to be able to use it. But when building the connected AI platform, it was actually not an either or, but instead like we have chosen a hybrid approach, which enables us to take the best from both worlds. So we decided to go with Kubeflow, which is open source, and combine it with basic services from AWS, for instance, S3, ECR, SQS, and also managed services. So the user can still trigger manage the SageMaker processing jobs or glue jobs from their Kubeflow pipelines if they prefer to do so. Next question before jumping into the actual features and architecture of the platform, what kind of use cases is the platform built for? So the connected AI platform serves all kinds of use cases that are in the domain of connected drive vehicle functions. And these features will become more and more smart with the help of data science. So some example use cases are, for instance, proposing the appropriate charging station for electric vehicles, or supporting BMW drivers and finding the gas station or a parking spot that fits to the current situation at hand. Then also, for instance, the smart regulation of the in-car climate, or then there's also the BMW Intelligent Assistant, as well as the My BMW app. One concrete example I can walk you through is the smart vehicle maintenance use case. So it starts all with the customer at the top. So if we get the consent for data collection in the car, the drive data is transmitted to the BMW Cloud Data Hub. And then from the Cloud Data Hub, the data scientists can access the drive data to develop their model that identifies a maintenance need. And then with recurring batch prediction runs, the model identifies vehicles that need maintenance for particular parts, for instance, the starter battery, and store this information in a database. And then this information can be retrieved by other backend systems, such as workshop tools, the My BMW app, or a service consultant, which you can see on the right. And then obviously the goal is that you as a customer don't have to spend a cold winter fighting with your broken starter battery, but instead can get a new one right before such an event would happen. Okay, let me get to the next slide. Oh, I managed to do so. As you saw, there's no data science without data, and hence customer choice and consent. This is very crucial. And also, in general, data privacy and ethics is so important now, even more in times of generative AI. So also we as a company have developed a dedicated code of ethics for AI that we strongly follow. And you can also access it by scanning this QR code. But yeah, the stream, it will be available as a YouTube video afterwards, so you can scan it afterwards. So then this was kind of the intro, like, okay, why do we want to have a platform? Do we want to build it or buy it or something in between, and some use cases? And now let's really dive into the actual features and architecture of the connected AI platform. So what are the core features that we offer the data scientists that we currently have? So I'll use this data science workflow again to walk you through the features that we have in the connected AI platform. So it's, I mean, we do have this main user entry point, and then we have something for data usage and storage. Then we also provide the developer environments. The data scientists can define and execute pipelines with Kubeflow pipelines. They can serve their models. And then we also recently have introduced model monitoring and visualization. So let's walk through this. The main entry point is Kubeflow. So Kubeflow is open source, as I said. It comes with a UI out of the box, which is very handy for us because on the one hand, we didn't want to occupy dedicated front-end engineers. And on the other hand, we still wanted to have this one-stop shop for data scientists, as opposed to having like multiple UIs and links and everything. And then similar to Kubernetes, let me actually see if I can have a laser pointer. Yeah, now you should be able to see it, right? So similar to Kubernetes, Kubeflow has the concept of namespaces that you can choose here at the top. So you have multi-tenancy. And then on the left-hand side, you basically see the core components. For instance, the notebook server, you can attach volumes to your notebooks. Then you can define pipelines and run them. You can define recurring runs. So if you want to train your model every week on fresh data, that's what you can easily do here. And then what's also convenient is, okay, so these are the core components that are provided by Streamlit out of the box, but then we also wanted to provide Streamlit and Grafana, and we wanted to have this one-stop shop. So you can supply this by jump-off links. So if the user clicks on Streamlit, then another browser tab is opened with the Streamlit UI, and same goes with Grafana. Yeah, we also thought about integrating it as an iframe directly into this page, but it wasn't possible by now with our current technical setup. But we might revisit this decision. But for now, it's fine. Then, so in addition to the Kubeflow UI, the user has the possibility to access our platform in different ways. So it really depends on multiple things, which access point is best for a particular, let's say, skill level of a data scientist, preference, or the needs of the situation at hand. So we do have a Python package that provides some helpful functionality around, for instance, AWS, authentication, and also eases the interaction with Kubeflow pipelines. Then we have exposed some of the functionality of the Python package as CLI commands if the data scientists want to trigger the commands from their shell or want to integrate it in their shell scripts. And then on top of this, we have prepared GitHub workflows that makes it easy for the data scientists to upload, trigger, and run their pipelines on their Kubeflow instance. For this, we have received especially good feedback because the user doesn't need to set up anything on the local machine. So yeah, they were very, very happy for this because then, like, even in theory, a product owner would be able to just run the pipelines and deploy a pipeline. That's very handy. Then, if we go along the, if we start with the data science workflow, you need to be able to access relevant data for your use cases. So that's why we also offer access to the most important data sources within BMW. So as you learned from the smart vehicle maintenance use case, depending on customer consent, BMW is able to access live data from vehicles. And then as a machine learning platform, we also have set up a connection to the Kinesis streams, bringing in the data. And then, for instance, there will be data such as the speed, location, some surrounding data, I don't know, door and window status, so anything you can think of. And then in addition to that, in addition to the live stream of data, we also have the historized way. It's called the Cloud Data Hub. So yeah, this is what they can also access. And behind the scenes, like, Cloud Data Hub is lots of S3 buckets. And then also if the data science want to store their data and artifacts, I think that's very, very like a common approach to just provide S3 buckets, right, for anything that they want to dump. Next, so now the data scientists, they have luckily access to their data. Now they want to explore it in their preferred development environment, which we offer in the form of Jupyter Lab. So yeah, I mean, every data scientist needs a space for exploring data, testing some code, some functions, or maybe even showcasing code to stakeholders or colleagues. And it's really also like, again, a huge benefit if they don't need to set up their local machine, but can do everything in the cloud and also with the Kubernetes resources under the hood. Same as with the GitHub workflows. That's like at the beginning we thought, okay, it's not that valuable, but then yeah, that's the feedback that we got, and we're also very happy about it. And then usually we only aim for, let's say, one tool per purpose. So we want to make sure to not accumulate multiple tools that actually might solve the same problem or an overlapping space of problems, because every additional tool as a platform means additional maintenance effort. But over time, we also saw that there are some data scientists that feel well comfortable with Jupyter Lab, and then there are other like sophisticated developers that really need a full-fledged IDE. So we decided to provide a base Docker image for spinning up a Visual Studio Code server with all the necessary base packages and configuration. So then, okay, now the data scientists have explored their data, maybe in Jupyter Lab or in Visual Studio Code, and then they want to start structuring the code into sensible steps and write pipelines. So this is why another core feature of our platform is the ability to write Kubeflow pipelines in Python. It gives the possibility to run steps, for instance, based on some conditions. So if you have some data quality check, you can configure, hey, you only want to run that model training if the data quality step turned out to be good. Also, you can, if you want to use the full resources of the Kubernetes cluster, you can execute steps in parallel. As I mentioned before, you can also configure recurring ones, because most of the time it's not enough to run and train a model once, but you want to retrain it based on fresh data. Yeah, so that's what Kubeflow pipelines is about. I guess like every company has like either, I don't know, Prefect or Airflow or Kubeflow pipelines. Yeah. So then after you have trained your model with your Kubeflow pipeline, the data scientist can decide to expose their model live as a REST endpoint. So obviously, okay, they can also do batch prediction, but we also provide the possibility of REST endpoints that run in our clusters, in our Kubernetes clusters. We have them in different regions across the world so that we can also ensure low latency. So it's like Europe, USA, and China. And then the live endpoints are available to be reached from the My BMW app or the car. If the car is in a, like, so to say, connected drive market, yeah, so it's not like 100% of the fleet, but yeah. And then, yeah, I mean, the overall cluster setup just enables like high availability. I mean, that comes kind of shipped with Kubernetes, right? And then also auto-scaling of the data science, so microservices. Now, after serving your model, or what we also recently introduced is model monitoring. So we decided to go with Evidently AI for metrics computation and reports. So we offer classification and regression reports, and then also data and target drift, because these are the most of our use cases that we have by now. Are these kind of models. So, and then Evidently is an open source Python package. I think it also like is very popular by now, at least like in the bubble that I am on LinkedIn and blog posts. You can tell me if that's true for you as well. But yeah, it's an open source Python package that provides the metrics computation and reports for those common data science problems out of the box. And then for Kubeflow pipelines, we have decided to provide reusable components that can be plugged in as a step to the pipeline at hand. So for instance, then here, one of the steps would be to just generate this HTML report that you can see here on the left-hand side. And then, so we expose it as HTML report, which you can see here on the left-hand side, but also as JSON file. And both of them can be also accessed from the Kubeflow Pipelines UI and are stored on AWS S3 under the hood. So the HTML file is usually used for visual debugging, while the JSON file is used for subsequent steps in the pipeline. Yeah, if you want to conditionally run steps based on a certain metric threshold, for instance, you only want to run the next step if the drift share is not 0.2. And then in addition to that, our Kubeflow components also store the single run to so-called multi-run tables. So you can see the timestamps here, and every row is basically one run. So one metrics computation run. And because that's also what our users really like. That was one of the first feedbacks, like, hey, we want to be able to compare the runs over a bigger amount of time. That's why we decided to provide this multi-run table. And then in the future, we want to further improve the setup for live serving models, for instance. And I mean, this setup can be used for live serving models as well. But I mean, we decided to really focus on batch prediction models first, and then do it step by step. And then also we are doing some first hands-on testing with alerting based on the computed metrics. And thinking about how we can use maybe Prometheus Put Gateway and then Prometheus Alert Manager. So the last feature I'm going to share is Streamlit. So we realized that when showing a POC demo of a data science model to business stakeholders, data scientists at BMW really oftentimes use Streamlit. So because maybe it's very easy for them to set it up. Everything is in Python, and they can set up simple dashboards with some sliders, for instance, to adapt the input parameters of their model. And that's like they're using it to explain it to the business users, the impact of different parameters to the prediction outcome, if they need to convince them that this model is super good, for instance. And then that's why we also decided to integrate it as a platform offering, because then also they can reuse this evidently AI HTML files, or also this multi-run table, which you can see here. And since it's Python code, they can do basically anything that they want. So that's also like an important factor. Actually, everything that we offer needs to be customizable, because we always have a certain use case in mind, and maybe it fits like, let's say, 60% of the use cases, but then there are always special needs that needs to be accounted for. So right now, we as a platform team are handling the Streamlit Helm chart, the deployment and auto-scaling of the instance. And then we also have an example repository with a CI workflow that they can automatically update their dashboard. So they don't have to think about, okay, how can I now reach this Streamlit instance? How can I connect to the Kubernetes cluster? They can just trigger the CI workflow. And then in the future, based on user feedback, we're also considering maybe to offer a full template repository with a so-called copier to provide Streamlit dashboards. But I mean, we will first see and collect some more user requirements. And then we also are thinking about using Grafana for really or visualizing live data. If you have a live serving model, then maybe Streamlit wouldn't be the best choice for you, but instead we would guide them to use Grafana, which we have set up for system metrics already. Okay, we made it through the whole features. Let's shortly talk about the architecture to see kind of like the big picture now. So at the bottom of this picture, you can see that we're relying on AWS as a cloud provider. On top of this, we have the so-called BMW Connected Services Cloud Platform, which basically is the Kubernetes cluster and also handles the user access management as well as observability with Grafana and Prometheus. And then we have built our connected platform on top of this, and which like the use cases and ML applications can then take advantage of it. This architecture graphic is sort of summarizing all the features that I've shown before. I won't go into the detail because, this YouTube video is available later, so you can check it out. I just will give a rough overview that here you can see the data sources that we collected, the vehicle shadow, and also the cloud data hub. Then here you can see the Kubernetes cluster with all the observability and access management set up. And then here inside, they can just write their Kubeflow pipelines and serve a model and store stuff to S3. And then the vehicle shadow and my BMW app and customer portal are the consumers. And then at the bottom, we do have our users, which I will talk about later. And then also us as DevOps engineers. So we have we provision the platform to the use cases account via Terraform and Helm charts. So I'd say we use a very common tech stack for DevOps. So as I mentioned, we use Terraform to provision AWS infrastructure, plain Kubernetes resources, as well as Helm charts, but and GitHub workflows. But in the future, we also like to be honest, super hyped to try out GitOps and are evaluating Flux and Argo for that matter. So basically with GitOps, tools such as Flux or Argo would constantly monitor your remote Git repository where you have stored your source code. And then once detected, such a tool would sync the changes in the GitHub repository immediately with the resources on the Kubernetes cluster. So yeah, please fingers crossed. We're very excited about it, that we can soon switch to it. And then, yeah, instead of using Terraform to provision Helm charts, because we saw some shortcomings maybe. So much about all the features and architectures. I would say now we are at maybe 70% of the talk. If you're considering, I don't know, if you just want to know how long it takes. So now that we have rolled out some AWS infrastructure and Kubernetes resources, the question is it enough to simply wait for data scientists until they start using it? The answer is no. So same as it's not enough to develop, or at least for our company. I mean, maybe in your company, you have data scientists who right away just check the documentation and then just do it on their own. But for us, like these were the kind of situations that we ran into. So I would say same as it's not enough to develop and manufacture a car. You would like really want to invest some time and effort into building distribution and support channels for the user or car driver. And that's exactly what we're doing for the connected AI platform at BMW. So for that, for that purpose, we came up with a setup consisting of 2 Scrum teams. As you can see, we have a so-called platform team and then 1 use case enabler team. The platform team maintains the existing features and ensures platform stability, but also develops new features. And then the use case enabler team takes care of onboarding new data scientists. They are very good in showcasing new features, developing use case specific features, and also like take care that the documentation is really like easy to digest, and they are also collecting the requirements. And at the beginning, when we started off in end of 2021 or beginning of 2022, we only had 1 platform team that kind of did everything, and we were not sure if it's worth having a separate user-facing team. But now, working with this setup for 10 months by now, it shows really that it makes sense and pays off. So yeah, and then the background of the developers that we have in both teams is data science, data engineering, DevOps, and cloud architects. Then different type of users. So at BMW, there's a range of data scientists that we're onboarding to our platform. So they really come with a different educational background and aspirations. So if we're thinking about a scale of data scientists and sketching out the extreme ends, so here speaking in pictures, like on the left hand, we have this very proud first-time data scientist who can, who was able to execute the code without any error. And then on the other hand, we have a very like a very, very knowledgeable data scientist who knows anything maybe and doesn't even need a platform, who knows. But yeah, so on the left hand side, to give some examples, we would have maybe a data scientist with a background in research and new to Python coding, and maybe this data scientist has worked with R or MATLAB in their previous assignments, and then the data scientist doesn't even maybe want to get into software engineering best practices, so they are just well occupied with the research on their algorithm stuff. And then on the right hand side we would have data science teams that have a very good software engineering background and can even maybe write down Terraform code. That's what we also have at BMW, that they are fluent in Terraform code, which you would we personally didn't expect it, to be honest. And then they might not even use your ML platform right away, but they have maybe created some custom tooling that they prefer to stick with. So that's a kind of user type. So that those were the extreme ends, but then we also have users in between, obviously. So how can we make sure as a platform provider to fulfill to successfully do the ramp up and onboarding for this whole scale of data scientists? So therefore, we in order to supply this, we have different phases of a project, of a data science project. So we came up with this threefold process. We have the initialization phase. So there first, we want to get to know the use case, see if it's a fit, if it's production ready, because if it's a use case that just started off their first couple of Python code, then we don't need to set up a Kubeflow instance or namespace for them maybe, but just be back in a couple of weeks maybe. And then in this initialization phase, we would also discuss the requirements and identify potential roadblockers very early on if they need some special stuff. And then we go into development. So the data scientist gets their own Kubeflow instance or namespace, and then a dedicated onboarding session. And they can start implementing their machine learning pipelines here. And they can also deploy or start to build the prediction service as a Docker container on Kubernetes. And then here on the right, we have the operations phase. And then here they can run their recurring executions of the machine learning pipeline. It's monitored with Grafana. They can also access the Kubernetes cluster with kubectl or K9s. And then so this is the overall process. And along the process, we have different formats to onboard different kind of users. So I let this sink in for a couple of seconds, and then we can go from top to bottom. So for the documentation, I think it's a very obvious one. I still wanted to to just share it, because oftentimes documentation is something no one would put in their CV hey, I've built great documentation, right? So that's why I just wanted to emphasize it, how important it is also as a developer to be able to write good documentation. And actually during all three major steps of the process, the documentation is important for the user, and it's also important to consider that each phase in a process the kind of questions and level of detail that the user needs are different. So that's why we have structured the documentation in a way to first give some very high level information, like a starter guide, and then we have some deep dive sections for particular topics. Then next we have the onboarding checklist. So as I mentioned, we do have these onboarding sessions that we do with each use case, and therefore we have prepared the onboarding checklist. So in this checklist, the users have to test and confirm that they can access every relevant resource. It's for our case, it's for instance the Kubeflow UI, AWS, GitHub, Microsoft Teams. So you can imagine it's a lot that you need to be able to access. So even though we're aiming to provide a one-stop shop, it's still a lot of accesses. And then we really realized that the users can better follow along the interactive onboarding session if all those access and installation problems are solved up front. Because we've been to situations we want to explain our super cool features of the platform, and they are not even able to clone the Git repository, for instance. So I mean, that's a very now if you think about it in hindsight, it's a super easy trick, but yeah. We didn't do it from the start. Then we also have a template repository. We have built it with a Python package called Copier. Copier uses Ginger under the hood for the templating logic. And then with Copier, we can prepare, or we as platform team prepared a basic directory file and code layout to kickstart their first data science project on our platform. So the user, with this templating logic, the user has to input a couple of data points initially, for instance, the AWS account ID, the region, or the product name. And then once they have inputted that information, a repository is created that contains a startup Kubeflow pipeline and also the mentioned GitHub workflows that they can directly use to interact with their Kubeflow instance. Then I think this is also somewhat obvious, like to have a weekly Q&A, right? Some walk-in sessions. What we also learned over time, that it's helpful to have a Confluence page or any other page. Just the idea is that people can put their topics beforehand. So like this has one benefit, that the use case enabler team can like check the questions beforehand and do some research, or already like come with a prepared answer to this Q&A session, which is very nice for the user, right? Because oftentimes they don't expect it. They think it's being solved during the session, but then actually the use case enabler team has already prepared for it. And then another benefit of having this Confluence page up front is that other data scientists can also join for particular topics that they are interested. Because coming back to the different type of users, they are the ones that don't hesitate to shoot any kind of questions to you. And then there are teams that like, they don't proactively ask, but they rather thankfully join existing questions and then say like, oh yeah, this is actually interesting to me as well, but they would have never extended this question on their own. Sometimes we also realize that like talking and reading and sharing is not enough. So, and then in these cases, we just offer ad hoc pair programming sessions, which is also like very cool for our team to just hands-on see the requirements of the users and see how they are doing on their machine, how they are using the platform. And then we have use case specific and also like a general chat channel. In Teams, we use Microsoft Teams at BMW. And then along the way, the user can also raise feature requests, or during operations, like sometimes they need to raise a defect ticket. So that's the kind of measures that we have for onboarding our use cases, but we're still experiencing, still gathering feedback, and we might come up with other measures to ease the onboarding process. Also like automizing it maybe with some starter YouTube video, not YouTube videos, but like videos that we can share on Confluence. So let's see what we will come up with in the future. Maybe people also want to share what they are doing for onboarding people, would be interesting as well. Then in the next couple of slides, I'll show you some of the things that we also like learned over time, some best practices when building a machine learning platform. And then this is like the last chapter before jumping into learning resources and the Q&A. So I kind of derived this not only dev, but also ops from the term DevOps. So all the learnings will be in this format. Not only dev, but also XY, which basically means like it's not only about developing a machine learning platform and releasing it to the wild, but there's more to consider. And coming back to the DevOps example, it means that companies should not only focus on developing new features, but also strongly tied together with operations. So first example is when developing a machine learning platform, you do yourself a favor if you really carefully think about adding new tools. So I guess lots of people here know those kind of tool landscapes that are released on a yearly basis. And then if you just compare 2012, where we had like 140 tools, and then by now we have like 1.5K tools, which is really crazy. So also as a ML platform developer, it's not only about like developing the features, but also like really carefully think about which tool you want to integrate, which is a fit to your current architecture. That was really a learning. Oh, and actually I also had a slide here to just overwhelm you with this massive amount of tools that we have for selection when you're like working in data and AI. Anyone? I mean, I on purpose made it that way, like you don't need to be able to see it, just to see, okay, it's a lot. That's the message of this slide. Then next example is also not only about developing new features, but also sometimes about not developing a new feature. So not every feature request of a data science team can be mapped one-to-one to an existing platform feature that is relevant to all the platform users. And then also sometimes the user approaches you describing their problem at hand. And sometimes they also approach you with a ready-made solution that they have in mind because they have some previous experience, maybe in previous companies. And then if they propose a certain solution, it really doesn't hurt to ask for the underlying problem in order to be able to propose for instance, propose an alternative solution or explain how the problem can be solved with the existing stack. So we also had these situations that they were asking for new features, and then we were able to say like, hey, 90% of your feature that you're requesting, we can already achieve it with the existing tool stack at hand. And then it's rather about giving a pair programming session instead of adding a new feature on top of it. Or we also had use cases reaching out that they need a feature store, and then we dive deep with them and realize, hey, it's a batch prediction pipeline. So for now, it's also fine to just store the features on S3 instead of setting up a full-fledged feature store. Yeah, so most often, to sum this up, most often the true solution is kind of, to have a well-maintained backlog, and then also to have your overall architecture and system design in mind whenever considering adding a new feature. Because it's that's also some other tech lead shared with me. It's very easy to introduce a new feature, but then if you have I don't know, let's say 200 users on your platform, then don't ever consider removing it. If you that will be very hard. Another one, so it's not only about developing and releasing the ML platform, but also there's a need to manage the developed piece of software, same as you would do with a product. So this is also a technique that ThoughtWorks suggested in their 2023 version of their technology radar. So they straightforwardly propose to applying product management to internal platforms. So I think for end-user facing products, it's very clear to everyone that you need to apply product managers, you want to have a product owner, but for internal developer platforms, I think it's still an evolving pattern. So there are companies that just do it by default, it's very clear to them, but then maybe in other companies, you have to convince people that, even though it's only a piece of software, you still want to have a proper product management. So if there's, because it's also hard to find product owners, people who are not developing them, who are willing to not develop themselves, but are still brave enough to be in contact with all those software engineering heavy topic. If there's any person out there that's super hyped about data science, but doesn't want to develop code themselves, then please consider to be a data science product owner. I think that's also a very rewarding career path. And then there's another species that are also very hard to find if you want to build a machine learning platform. So it's not only about finding it's not only about developing the platform, but also finding the developers that actually want to develop this platform. So it's really there are lots of people that want to work on modeling because this is just such an appealing topic. And actually I also started as a data scientist in 2018 and only then transitioned to machine learning or MLOps over time. But then when it comes to people who want to work in the backend, really building such a platform, the amount of potential people decreases heavily. So just to do some more promotions for ML engineering and MLOps. So in the end, as a data scientist, and please no data scientist should take it personal, but as a data scientist, you will only be able to bring a handful of ML models to production, while you can guess it, as a machine learning platform engineer, you might be responsible of hundreds of use cases in production. So let me know if you still need some more motivation. I can pop you on LinkedIn about this then afterwards. Okay, that's it about not only dev but also XY section. Now let me share my favorite learning resources, and then we can jump into the Q&A. Introducing MLOps. This is a great starter book for people that are aiming to learn about more about MLOps concepts. Then there's also architecting data and machine learning platforms. It's still a pre-release, and then it will be fully released hopefully by December. But yeah, I bet this will be pretty insightful. I mean, it's from O'Reilly and the title just fits perfectly. So I'm very curious to dive into it once it's fully released. And then I've also chosen Pragmatic Programmer. Like, why? It's not a book related to machine learning, but whenever a non-tech person asks me what I'm doing for a living, my answer is I'm a software developer, because oftentimes like the people don't know about this distinguishing between data science and data engineer, and then machine learning engineer and ML ops. And then also in the end, that's what we as developers working in the field of data are. Like, we're building software and helping to integrate data-related applications with the rest of the application landscape of a company. So that's why I think it's always like, never hurts if you also like add some pragmatism to this very complex field of data science, algorithms, and modeling. Yeah. Then some online resources. So from left to right, I stumbled over this awesome list of ML platforms that is maintained by Evidently AI. If you have a platform, you can reach out to them through their Slack channel. They can add your platform to it. And it's basically just like a link tree of listing companies with nice ML platforms, and then also like resources. Then there's the ML Ops page. It's like blog posts. It's also a very well maintained source of content. And then obviously that's what we're here for. It's DataTalksClub. I mean, we have the newsletters, the online streams, the Zoom camps, which like congrats on the trending GitHub repository. So this is very valuable. And then I have to also put this in. So if you're a student in a bachelor or master's program, then obviously another great source for hands-on learning is an internship, for instance, at BMW. And the shown internship is actually in the department of my colleagues and me. So you can apply for it still, but please be aware that this particular job description with this with this ID that you can see here at the bottom, it will be closed soon. It will be taken offline, but we will create a new opening for the next round of internships. So if you cannot find it, then you can approach me on LinkedIn to ask for it.
Is it only for people based in Germany or worldwide?
And if you are enrolled in a bachelor or master's program, so
anywhere, right?
It should also be possible to get a visa. Okay. Working visa.
It's not a remote one.
No, it's in, like we would prefer in person. Sorry for that.
Well, I just assume people would have questions about that.
That's true. Let's see. Okay, and then last slide. So we can connect on LinkedIn, and I will be in Berlin end of June for the Women in Data and AI conference. And let me know if you're around, because I'm always happy to meet in person.
Okay, I'm just curious if, I think, do you see any problems with the stream? So people watching it through YouTube, please let us know that everything is fine, because for some reasons on my computer, everything froze. Hopefully everything is fine. So we will continue as if nothing happened, but when I see in chat that somebody says something is wrong, then we'll think what to do. Okay, and now what I will do is I will ask you to stop sharing your screen. I will share my screen with the questions. And thanks a lot for the talk. Like, it was amazing. And thanks also for your shout out to DataTalksClub. Okay, and I see that everything is fine, so that's good. And we will just start with the questions. So the first one, the most voted one is, Magdalena, how was your professional transition from data scientist to MLE? What were the biggest challenges?
So this transition from data science to MLE happened during my job at Delivery Hero. So there I joined as a data scientist in logistics, but then the models were like of very high scale. So we had lots of models, and then we also the models were called like a lot of times, like millions of times per day. So it was really crucial that all the Python code and the microservices and Helm charts on Kubernetes are set up in a very stable way. So that's why like we had a team of I think 10 to 15 data scientists, and then we have picked like 4 of the data scientists who are most interested in all the Docker and Kubernetes stuff. And then we kind of founded this ML engineering squad. So it was on a job, and the biggest challenges, I mean, of course, I had to learn like Terraform and Helm and Kubernetes and everything, but already during my time as a data scientist, it was just necessary because the system engineers would always be busy. So if you can do it on your own, like you can just solve your problems quicker. Yeah.
Okay.
That was kind of the transition.
And it seems like since you worked in logistics, you probably know Alex, who was my manager at some point too. But
yeah, of course. Yes, search metrics, right? I think I saw it.
Yeah, exactly.
Yes, he was my manager back then.
So such a small world. Okay, do you have any use cases which use GPU? And what was your experience with the GPUs?
Yeah, so for that, like I would say not a lot of use cases use GPUs right now. So that's why we have decided for these kind of cases, they can run SageMaker processing jobs, and then they can easily, they can choose the GPUs, the underlying, but of course, it's more cost intense. We do have a labeling system in place that we can attribute the cost to the use cases. That's the status quo that we have right now.
Okay. How big is the ML platform maintenance team? How many data scientists use the platform?
So the platform team, we are 15 people, but like we're not only but I think that's what you mean by the question. So this platform team is responsible for maintaining, operating, and also adding new features. And then we have right now around 20 to 30 use cases, and then each use case, it depends. It can be like one person who's working on the use case, or it can be like 10 people who work on this data science use case. So maybe I should count for the next presentation.
And in terms of data scientists, like in terms of users, 20, 30 use cases, and it's like, I don't know, 20 data scientists, 15 data scientists, something like that?
Sorry?
Like, the second question, how many data
scientists? So the second question is like we do have 20 to 30 use cases, and then each use cases, it can either be one person that's working alone on this use case, or like we also have teams of 10 data scientists who are working on a very like complex problem.
See. So yeah, at some point you mentioned that you use Terraform and Helm, but there are some shortcomings. That's why I think you were considering CI/CD, right? Or GitOps. I think it was GitOps, right? So what was not working for you when it comes to Terraform and Helm?
Yeah. So, I mean, there's, so if you have like a GitHub workflow that is rolling out some Terraform resources, like, of course, you have the Helm resource, but then it's like you always have to roll out the whole resources, which can take up to like more than 30 minutes. But then if instead you use GitOps, then it would just like update one particular Helm chart and not like go through all the Helm charts, checking in with the AWS infrastructure again. And even if you don't change anything in a Helm chart, it still consumes some time. So that was something. And then also we ran sometimes into resource conflicts. And that's something that we hope to improve with GitOps.
Mm-hmm. So resource conflict is when two people are trying to apply Terraform stuff, right?
Yes.
Okay.
Yes.
I have run into this too. So, okay. I don't know if you can answer this question, but are you working with any vendors?
Yeah, I mean, me neither, to be honest. So, I mean, it's a mixture, right? So it's a mixture of internal and external developers. And yeah, obviously, like AWS is one of them, but we also do have other people who support us.
Yeah, so I was also wondering about this one. So you use Copier, and I was wondering, like, why not Cookie Cutter? Because typically it seems like this is the standard, or at least this is the most popular tool. So why did you choose Copier instead of Cookie Cutter?
Yeah, that's a good question. So Because I can tell as a joke, it's very hard to whenever you need to Google for copier, it's hard because it's such a random name. I mean, also in my former company at Delivery Hero, we used Cookie Cutter, and then now we are using Copier. But so far, to be honest, I cannot tell a main drawback. So I think both of them offer this templating logic. I mean, both of them use Ginger under the hood. I mean, one might argue that the updating logic of Copier is easier. So it's not only that as a data scientist, you want to create a repository out of the template once, but then once you have created it, and then we as a platform team offer more features, then we want them to update it. And that was sometimes difficult with Cookie Cutter. So that's why we decided to go with Copier, kind of.
Okay. So how do you handle continuous scaling of the ML system once it's deployed in the production? By continuous scaling, I assume it's like horizontal auto scaling.
So that's a question. Is it about the ML service that is running on the Kubernetes cluster? Is it about the training?
Well, I would assume that if we talk about being deployed, then probably it's about, the service. But
Okay, that's what I assume as well. So we use Kserve for the model serving, and then there we can configure the horizontal auto scaling. So if one pod is not enough to serve the traffic, then automatically more like replicas of this pod will be booted up.
So Kserve handles everything, and it's based on, I don't remember, is it based on request per seconds, or how do you configure it?
Yes, for instance, that's one option. Or for instance, like resource usage, CPU and memory.
Okay, can you explain how you perform continuous learning?
Is it me as a professional or at the platform? I mean, me as a professional, I mean, I read books and also try to follow with online resources. So it's a mixture of both. But also what's a very valuable resource is just talking to other people. I mean, I did a computer science degree with a data science focus. So there I have a lot of people who are now in the industry, and I can exchange with them or former colleagues. That's really a very valuable resource to see how they are doing, how they are solving things.
I'm just not sure if continuous learning refers to some concept from machine learning, or it's about your personal development. I was not sure too, because maybe it's about online learning. But I think we can treat it as solved, and then maybe answer one or two more questions depending on how much time we have, because we have only 2 minutes left.
Okay.
So is it possible to install individual Python packages for data scientists, or everything has to be pre-installed?
So we have both. So we come up with base Docker images, for instance, where we provide an opinionated set of Python packages. We try to keep it lean, but then they can also install their custom packages on top of it.
Because in Kserve, you can use custom images, right? So do data scientists do everything themselves, or they need to talk to you before running a new project?
So we do have the Terraform pipelines, and then we do have a YAML config file, and the people, if they want to configure something, I don't know, adding a new name, like a new user email, or they want to enable Streamlit, or they want to configure some monitoring threshold, then they can go to this YAML file, and then they can open a PR and configure it. And right now we are still we do have some CI workflows in place that test the schema and everything, and if it's valid, but still we as a platform team then approve and merge. But in the future, if we have good enough CI workflows, we would also be confident enough that the user can do it on their own.
Oh, thank you. And unfortunately, there are still 11 questions that we could not answer, but we're running out of time. I don't know, is there any way to follow up with you for people who asked their questions but did not get an answer?
Yes, sure. They can approach me on LinkedIn.
Okay. That's the best way for reaching out. Yeah, so today's session was really good. Like a lot of people joined. Thanks a lot for joining, for being active on the chat, for asking questions. Thanks a lot, Magdalena, for presenting this. You're doing really cool stuff. I also wanted to ask a lot of questions, but yeah, it's a very interesting topic. And I hope it was useful for you who watched. Yeah, I think that's all. So have a nice evening, everyone.
Yeah, thank you. Thanks for organizing and joining.
Yeah, well, speak soon when I'm in